Ghrelin is a newly discovered hormone found in 1999 as the endogenous ligand for the growth hormone secretagogue receptor. The growth hormone receptor was found a few years earlier and was known that it could trigger growth hormone, hence its name. And so ghrelin was found to be partly responsible for growth hormone release, but then it was found to control appetite. It was nicknamed the hunger hormone. Ghrelin does this via the hypothalamic pathways. Ghrelin is a 28 amino acid peptide that is mostly secreted within the stomach and then into circulation. The fundic cells within the stomach and upper intestines secrete ghrelin, but secretion also happens within the hypothalamus and the pancreas, but in smaller amounts. Ghrelin to be active must be acylated. This creates two forms of ghrelin. Acyl ghrelin has an acyl group or fatty acid at its third position. Desacyl ghrelin is not active, though there are theories that it still does contribute to body function. Acyl ghrelin is the form that activates the growth hormone receptor and is involved in appetite regulation. So how does ghrelin activate the neurons of the hypothalamus to increase hunger? Ghrelin increases AMPK phosphorylation within hypothalamic cells. To do this, ghrelin binds to growth hormone receptor and begins calcium release. Increased calcium levels within the cell combines with calmodulin to stimulate CAM-dependent protein kinase. This leads to AMPK phosphorylation, causing an increase of NPY and AGRP neurons, and so hunger is felt. Ghrelin also inhibits the POMC and the CRAT neurons, which are responsible for inhibiting appetite. The stimulation for all this starts within the stomach when it's empty. The secretion of ghrelin stimulates the vagus nerve, which tells the hypothalamus the nutritional status of the stomach. Ghrelin can also travel via circulation to the hypothalamus and is able to cross the blood-brain barrier. Once the hypothalamus receives a hunger signal through its cells, NPY and AGRP peptides are increased. This causes increased motility and digestion within the GI tract. Another hormone, leptin, interacts with ghrelin in appetite control. Leptin, which is mostly secreted by adipose tissues, targets the same area of the hypothalamus as ghrelin, but its effect counters ghrelin's. It suppresses appetite. Leptin activates receptors found on POMC and CART neurons, which causes the release of alpha MSH, causing appetite suppression. Leptin also inhibits the NPY and AGRP neurons, the neurons that ghrelin targets. Ghrelin is considered to have a role in obesity, though exactly how is still being investigated. Ghrelin levels in those who are obese are low. It is suggested that the NPY and AGRP neurons have been damaged and do not function. Also, hypothalamic AMP activity is suppressed. Prader-Willi syndrome is a genetic disorder that ghrelin could play a role in, but once again is still being investigated. PWS patients have an excessive appetite, and it has been found that these people have very high levels of ghrelin in their circulation. It is suggested that genetic alteration has caused the hypothalamus to not function as it should. In closure, ghrelin has a great control of appetite regulation, as has been shown, but it has many physiological functions, as can be seen in this slide. Because ghrelin is a new hormone, many of its functions have not been yet properly explained. Only time and more investigation will show how amazing this hormone is.